My question, are people still awake, is not necessary. That's good to know. So hope the coffee woke you up for the last session of the day. So we're going to be talking about unit testing in JavaScript, and I'm going to be showing you some demos with this tool called Buster.JS that I'm developing together with a friend of mine. My name is Christian Johansson, and I've come from Norway. Whoa. What was that? Okay, so you will occasionally find me blogging about what? I'm sorry, this usually doesn't happen. That was strange. Okay, sorry about that. You can find me blogging at this URL here, and you can find me tweeting about various stuff under this username. I'm really nervous about the slides starting to run again. Anyway, I work at this company called Gitorious.org. Has anyone here heard about Gitorious? Yeah, wow, a lot of you guys, cool. So it's a web application where you can upload Git repositories and have like workflows that involves merge requests, and not unlike GitHub that some of you also may have heard of. This software is open source, so as a company we're trying to stay alive by helping other companies run Gitorious privately within their firewall setup. Then I wrote this book called Test-Driven JavaScript Development, which came out last fall. Has anyone here read that book? Oh, cool, thank you. And two more of you people will be able to do that, because I have 2 copies here. And what I thought we could do was to have you guys tweet something about this talk or the tool that I'll show you or whatever. Just tag these 2 hashtags on there, and I'll pick 2 random people at the end of the talk who will get a book. Okay, sounds fair? And this is actual random. I once did this at a talk, and then I searched Twitter and picked the last tweet, and I was heavily criticized for that. That was unfair. So this time it's completely random. How many of you guys are actively writing unit tests for JavaScript? Raise your hands. Okay, a few of you. So I see some people who said they read my book and didn't raise their hand now. Did you not finish it, or? Yeah, right. Okay, so the rest of you, do you have a faint idea of what a unit test is? I thought I'd explain you, actually by showing you what happens when you run a unit test. And to do this, I'll show you this small piece of code. So this is a method that I wrote called stirfTime, which is a function that doesn't exist in JavaScript. It comes from C, and you'll find it in Python and Ruby and PHP and probably many other languages. And what it does is to format a date. So you'll have a date object, you'll give it a string, and you have these characters that start with the percentage sign, which have special meaning. So the big Y gives you the 4-digit year, the small m gives you the 2-digit month, and so on. And I wrote an implementation of this, which works quite nice. You can imagine, like, if you have a newspaper with articles, you might want to use something like this to bring timestamps into something readable. But then it turns out there are some problems with this code. And I don't know about you guys, but I make stupid problems occur in my code all the time. So there's typos, and my brain produces flawed logic, and sometimes even the browsers are screwing up for me. And there's a lot of situations where errors can occur. And what you do when an error occurs in your program? Well, what? Somebody say, no? Sure. You write a test. Great. So you can just dive in there and hope that you find where the error came from and try to fix it. Or you can take a more structured approach. So the problem with just diving in there and fixing it is that you will have no record of that bug ever having occurred, which may make you experience that that bug comes back later. And I think that's probably the most embarrassing thing you can possibly experience as a developer is to have the same bug occur more than once in the same code base. That really shouldn't happen. That's unnecessary. So what I want to do instead is that rather than having an experiment running in Firebug or whatever, I want to do this in a structured manner. So the problem here is this last line where the percentage y should be a 2-digit year. It's only giving me 9. Okay? So it should have been 0, 9. So to test this, we only need a very simple HTML page that links in 2 scripts. And then we can just log some calls to this library. And I thought I'd show you this live. So this is the HTML page. Can you read this? Is that okay to read? Yep. And then I'll open a test file where I have a log function. I'm very sorry about the document right here, but this should have been, just pretend it's console.log. It's just that console.log is very bad for a big screen because the text is so small. Okay. So we'll convert these to log, and I can run this file. And then I can see the output of these function calls. And what I've done now is I automated a test, because I can run the same test over again without the manual effort of creating the test. So I can just hit reload, and the test will run again. And I can put it in source control, and I can run it in 3 months to check that all of these cases still work the way I want. When we're automating our tests, we want to automate like manual labor, such as running it and so on. And we want to have good feedback so we can quickly figure out what to do with these results. Right now, I cannot do that because there's nothing here telling me whether or not either of these are right or wrong. So let's start by adding that. I can just add a comparison like this for each step. Month, 12. So who here loves the consistency of the date API that has 0 based months and 1 based days? Great. Okay. Now I'll get some booleans instead. So this is slightly better because now I know that one of these is doing something wrong. But I don't know which one of them, and I don't know exactly why it's wrong. It's just not what I expect. So let's add a description too. That helps. So I'll say that big Y should be a 4-digit year. Okay? And I'll just add an extra description like this to each one of them. This will be different. So this is M, D, Y, and these should all be 2-digit. 2, and yeah, so this is year, this is day, and this is month. Okay, should be full date. Cheating a little bit. Okay, so it's getting better. Now I know that it's the small y thing that's failing. So that's good. However, when we want to improve the feedback we get, it's not just a matter of having more feedback coming out. It's about making the feedback more useful to us. And at this point, the only really useful feedback is that the fourth line, which tells me that one of my methods aren't working correctly. So to improve this, I can add another function, which is called assert. And assert simply takes a value, and then it checks if the value is falsy, we will throw an error. And we'll accept the message too, and pass it into the error, like so. And now I will replace my log calls, let's see, with assert calls. And now nothing happens because an exception is being thrown, which I can probably find in the console. So let's just wrap this in a try catch, like so. Catch the exception, and then I can log out something here, message. Boom. Okay, so now I'm only being told that one of my functions is not working. This is pretty good feedback. What's missing from this feedback is exactly why it didn't work. So I just know which one didn't work, I don't know why. So to improve this situation, I can add yet another function, which is called assert equals. And this comes from the reasoning that the assert takes a Boolean value of some sort and checks that it's not falsy, right? But there's more semantics to my tests here than simply checking random falsy values. I'm actually comparing two values all the way down. And by having the computer understand what I'm trying to do, it can provide me with better feedback. So this assert equals thing will take two values, and then it will call assert with the comparison. And maybe I should even up the ante here to triple equals. And then I can generate the message that we passed to assert. So I can say that I expected this value to equal this value. And now I can change these once again. So I'll say equals. There we go. Okay, so now I'm getting more information about the error itself, but suddenly I lost the information about the test. Oops. So I'm going to add one more function before we kill this experiment. So the thing here is that the assertion is throwing an error, which makes sense in a certain light of how you can view assertions. So assertions are used to test aspects of one truth, right? And these are actually different tests. They all test the same method, but the big Y and the small y are two separate paths. And if I had two assertions for the small y, like this, let's say I check the type, then I could logically say that these two assertions make up one test. And it makes sense to abort from the first assertion if it fails, because if one of them fails, then something is broken. I need to fix that before I can start checking other things. So we're going to create a simple test runner that can handle this for us. And I'll call it test case. It will cover the whole prototype.stirfTime method. And then we'll do some magic here again. Let's see. Oops. There we go. Function. Okay. There we go. So we have our test. Something went wrong. Okay, we'll just kill this one. And the test case function is basically just responsible for running all my tests and printing the result of each one of them. So I'll take the name and some tests. And then we'll just have we can log the name here, and we'll do a simple loop. Test name in tests. And we put the try catch here instead, right? Then I'll log. And here's the beauty of it, because at this point I have the test name and I have the information about the error. So I have both things at the same place. So I can say that it failed, and then I can add the message here. Test name, like so. Great. Now I get all the information I need, and I get none of the information I don't need. So this is pretty good. There's just one more detail I would like to fix here. And that is, if I now went on to fix this error, this is the actual code. Turns out I'm just missing a call to zero pad here. I fix it. Now I have a blank screen. And this is bad because, someone want to take a guess? Excuse me? Maybe it's a leading zero? No, I used triple equals, so the test is correct. The problem here is that I don't know if all my tests passed or if none of them ran at all. I can't tell, right? Because there's no output. So trimming the output, it goes back and forth. You can have too much and you can have too little. So now I have too little, and I can fix it very easily by simply adding, for instance, a counter in here. which starts at 0. Every time a test passes, I can increment it, and finally we can print out how many tests we run. Yay. Sweet. 5 tests passed. And congratulations, we have now created our very first unit test framework. This is all there is to unit testing, really. This is what it's all about. And from here on out, it's just a matter of improving the automation of these tests and tweaking the feedback we can get from them. So this is where Buster.JS comes in, where we try to take both of those aspects to the, I don't know, extreme, but we're trying to really make it a useful tool to work with. First of all, I want to just show you how this would look if we were to express it with Buster. So hopefully this looks very recognizable. It's almost the same that I just wrote, except that it's called Buster.TestCase and it's called Buster.Assert. So this is just a simple design decision we took, that we only want to expose one object into the global namespace to be kind, so we have to nest our stuff inside of that Buster object. And similarly, to run this, we have an HTML file which loads the library, my test, and the Buster file. So it's basically just the same. And if I want to run this, it looks like this. And here I've taken the feedback thing one step further by having a stack trace in addition to my error. So the stack trace will allow me, maybe not in this case, but in most cases it will allow me to find where the bug originated, especially if there's a bug or something that throws an exception inside my code. Okay, so why should I use a library for this when I can write these functions in 10 minutes? Well, there's some things we can do to make this test more pleasant to work with. So for instance, let me add another test here where I say that I should return a string. Let's say that this is very important. So I can say type of. So, okay, 2 tests on the top here. And notice that both of these tests start looking kind of the same. So there's something similar with them. Both of them are for the big Y specifier. So Buster allows me to group these using what we call a context, which is basically just an object like this. And when I do that, I can remove the prefix from each test. And when I run, you'll see they stack up to the bottom now, but the name is concatenated, right? Excuse me? I didn't hear you, sorry. Yeah, so I'm piecing together the names. And what's more interesting about this is that these are both testing on the same value here. So to reduce the amount of code you have to write, you can extract them into another one of these setup methods. So I may have skipped the explanation of the setup, but it is simply a function that runs before each test. Okay, so in this case, I actually have 2 setups. The one up here, which will run before every test. There's a typo. Yeah, it should. Thanks. And inside this group, both of the setups will run before each of the tests. And this still runs like expected. And in cases where you need more than one line of setup, this can be a really nice touch. So you can set up some base context for your test, and then you can have groups that have more specific setups. And the same goes for the method called teardown, which is run after each test. Okay, so let's say that while I'm working on this bug, my manager comes in and says that, hey, we need to know what day of the year a date is. Okay, a bit contrived, but let's say that happens. So, okay, what I do when I'm supposed to add a new feature, I always start with a test, because a test can describe how I want the API to look, and it can also describe like what's the expected output. And then I have something to check against, so I know when my code is working, but I also know that when I should stop programming, right? Because when the test passes, I have all the information I need. So this JSwitch here should return the day of the year. I'll add that, and the simplest test I know for that is to just take the first day of the year, which should be 1. Date, stirf time, J, and that should be 1. Okay. Great, so it fails, obviously, because I haven't added that feature yet. But now I have a problem, because I have 2 tests failing at once, which is really distracting. But I wanted to add this test like a mental note, so I don't forget to add that feature. And usually you could do like, I could comment out this, but that's problematic too, because that will set me up for out of sight, out of mind, and maybe I will commit it in a weak moment, and I'll forget all about it. So Buster allows you to basically comment out the name like this, when it will keep it in the report, but mark it as a to-do. So this is a nice way of keeping a to-do in your test file, reminding you of features that you're supposed to add. And it might look like a cute gimmick, but it's actually useful. I use this a lot. Okay, that's that. So let's go back to these slides again. So there's another problem here. Lots of problems. This scaffolding thing really sucks. The HTML file that we add just because the browser cannot run JavaScript files directly are just getting in our way. It's just manual labor. So we have something we call Buster Static, which can solve this problem. And it requires a small configuration because it needs to know what files we want to test. So let me go to my project here, and I add this configuration file. And this is actually a node module, but you don't need to worry about that. And we did some, this is just for looks, config equals exports. And then I say that this configuration is for browser tests. And these are my sources, these are my test files. And this can be actual full glob paths. So if you do like this, you will include every file in every folder inside the source directory. So given this configuration file, I can pop up, open a shell, and I can write Buster static. Okay, it started a server on 82.82. What's that doing? Let's see. Localhost 82.82. Hey, it's my tests. And I didn't add the HTML file. So Buster created the HTML file for me, which is kind of useful. And if I want to put this test up on my website to have other people run them, I can tell Buster Static to dump the files on disk by simply giving it a path like this. Swoop, and I get a link here where my tests are also running. And these files can just be shoved onto the server, and then you can host your tests online if you want to show the world all your tests and the status of your library. So this is just one of the ways that we've tried to make it easier to run tests. Now I want to look at another way we can make it easier to run these tests. So it so happens that the code I'm working with here, the stirf time function, is not really browser specific. So it could be equally useful on a server. So what do we have to add to this to get these tests running on the server? Well, let's try. I'll find my test again. So we simply need a very simple feature test to know if we're on the server or in the browser. And we can do that by checking for the require function and the module object. And if that's true, then we require Buster. And we also have to require our source library, which is called stirf time. So, and you can omit the .js suffix for these files. So this is just the Node module system. So now I should be able to say Node in my test file. Ouch. Can't find Buster. Ha. It so happens that we use the Node package manager, which is the official package manager for Node. And I have already installed Buster, so I can just say npm link Buster, and there it is. And I can run it again. And there are my same tests running in the shell. So this is the basic same thing, except it runs maybe even faster. And I can do it inside my console. And this allows for a couple of other nice features. For instance, if I don't like the way Buster formats my output, I can tell it to use another reporter. So here we have BDD console, which is a more verbose reporter, which will include the name of all the tests. So without modifying any of my own code, I get lots of choice in how I can represent the runs. And perhaps even more interestingly is that I can, because it uses environment variables, I can export this variable, right? And now a run will use that new reporter by default. So if that's the one I like, I can just put that in my shell configuration file, and it will always use this reporter. And then we have something for tool integration too. Let's see. There we go. So instead of BDD console, I'm now going to get myself some XML output, which looks like this, which isn't terribly exciting, but this isn't meant for human consumption. This is meant for tool consumption. And one tool that can make use of this is something called Hudson or Jenkins. Raise your hand if you've ever heard of either of those tools. Oh, a lot of you. So here are some projects that I've been running. I'll just show you an example here. The graph here shows the history of the project. So this is basically a server that's running tests on my code without my interference. So every time I push my code to the server picks it up and runs the tests for me. And if we see the last bill here, which was green, which means that it passed, we can see that there were actually 4 browsers running tests in this case. And if you have machines with browsers, this could have easily been 20 or 30 or 40. So this is what you use the XML output for, tools like this. Okay, but there are some even more nice things you can do on the command line, but then we have to add a little bit more configuration. So I'll go back to my configuration file, and we'll add one more of these blocks for the server. Oops. Server, and then I say environment node. And for node, you don't need the sources because the test is already requiring the sources it needs. So you can keep it there, it doesn't hurt, but it's not needed either. So using this configuration, I can run Buster test and say E for environment node. And you get the same output that I showed you earlier. Not very exciting. But now I can select reporters using -R, if that means anything to you. And I can also tweak other aspects of it. So I can, for instance, dim the colors if you don't like the bright colors, or you can turn the colors off if you don't like them at all. Perhaps more interestingly is that I can, let's just run this one more time, and this test is failing. Let's say I want to focus on this test. So I'll get the name here, and then I say Buster test E node. And now I'm running only that test, just that single test, which can be useful if you need to home into a problem to really isolate it. And you can even just provide parts of a name to run all the tests that match. Like so. So now I'm only running the tests that have %y in its name. Okay. So what about the browsers? it's kind of cumbersome to refresh that browser all the time, and especially if you want to work in a test-driven fashion where you write tests before you write the code, then you need to run your tests maybe as often as each minute, or maybe even more often than that. So jumping into the browser is a major context switch, which is really cumbersome. So, and it also makes it very hard to test multiple browsers because you have to run around each of your browser and, you know, refresh it every time you make a change. So then we created this thing called Buster Server to solve this problem. So has anyone here heard of JS Test Driver? Yeah, a few of you guys. So this is heavily inspired by that tool. Yeah, so what it does is basically it can instrument browsers remotely. So you can start a server and you can take some browsers and hook them to that server, and you can run tests from your editor or from the command line, wherever suits you fine. And the beauty of it is that you can test many browsers in one operation. So this comes down to the automation part again, that we're trying to make it easier to run tests. So let's see how that works. I already have configuration for browser tests here, so I don't need any more configuration. But what I need to do is to start the server. Okay, it's listening on port 1111. So I'll take my browser to that place, which gives me this screen. So I can hit the button here now to capture the browser. It basically just says that if you hit this browser, this button, your browser becomes a slave. Poor browser. Okay, so, and this is still a work in progress, right? So it's not completed yet. So this is actually doing stuff. It's just not showing anything. So this is part of the polish that we're hoping to apply before we go 1.0 to actually, you know, tell you that something is happening. Okay, so I'll just leave that browser there now. It needs to stay there and be a slave. And I'm going to go here to dominate it. That sounds very dirty. So I can say Buster test, and this time I'm not going to run the node tests, I'm going to run the browser tests. And there we go. So let's just fix this. We get rid of that long stack trace. I'm just adding the 0 pad call. Okay, there we go. So you can see now that Firefox 602 on Linux ran all my tests. And it's almost as fast as running them on Node, but this time it's actually running them inside the browser. And this is starting to get pretty useful. I can now start hooking up mobile phones and several browsers and so on, and keep running, and it will be basically as fast because the tests all run in parallel in different browsers, right? And at this point, you have access to all the other tools. So I could ask for XML output for tests to run in the browser, which was what I showed you before from Jenkins, which had actually run tests in this way. Okay. How are we doing on time? Whoa. Okay, so as I said, this is heavily inspired by JS Test Driver. They basically pioneered this way of running things. I think we've pulled it a bit further with some features that I'm about to show you now, and also the fact that it works equally well across the browsers and in Node. And we plan to also look at other JavaScript environments where you might be interested in running tests, such as WebOS. So, okay, the next part is about testing Ajax. And there are many ways of testing Ajax. The main problem with testing Ajax is that you're making an HTTP request to another server, and that complicates your test setup because you may need another server running in order for your tests to make any sense. So I want to show you a few ways to test code that uses Ajax without actually having to have that other server. And the first way is through another tool, which incidentally I also wrote. It seems a bit strange to only present your own tools, but here we are. Does anyone know signin.js? Yeah, a few of you guys. Okay, so it allows you to fake out the Ajax request directly in the browser. And this is how you do it. So in a test case, you can say signin.fakeserver.create, which creates a fake server which will now manage all your Ajax requests. And then we have this test. So this is from a to-do application. It's not very important, the details here. The point is that that list.add function makes a request to the server to add a new item. And then you can see that I'm checking here, server requests, which is now an array of all the requests made. So I can check that the length of that array is 1. In other words, that there were 1 request. And I can also check the details of that request. It should be a post request, it should hit that URL, and so on. That's one way to do it, but it's very it's very detailed. It's maybe too detailed about the request itself. So another way to do it is to actually define a mock server or a fake server or whatever you want to call it. And I'm using the respond with method here, which basically configures that server and teaches it a few tricks. And what this means is that whenever you see a post request to this URL, I want you to serve this response. So it should be 200 OK. It should include these headers, and the request body, the response body should be this string, which you can see is a JSON object with 3 properties. Okay, you with me so far? Yeah, just explain that. And yeah. And then I have this, this is the same test. I am now calling that add function again, which makes a post request to that URL. And then I tell my server to respond to all the requests it has seen so far. And then what happens is that I can check that the callback was called. So now my verification logic does not involve the actual HTTP request anymore. I'm just checking the artifacts of the API. So the API says that when you call add, when the server responds, your callback will be called. And that's now also the same thing that my test is testing. Rather than checking that we send an HTTP request, I have the server actually serve some stuff up and check that the callback is called. Okay, hopefully I didn't spin your heads off with that. Here's the full test. You can grab the slides later and take another look at it. I now want to spin this example a bit further and show you a couple of other ways to do the same thing, which basically moves in the direction of integration testing, which is testing through your whole stack, not just the unit tests. Okay, so let's find that project I was showing you. We have a server here. It should be, yeah. So here's the application. Yeah, I've talked about testing before. There we go, yeah. To do blah, blah, blah. And you can add items like this, and you can tick them off. And yeah, so it's a very basic application that where the server only has the data. So it serves up data, and you can add more data. And all the logic is in the JavaScript here. And the testing question is, let me find the test for you too. Integration. Okay, so here's the test. It's a bit simpler here. So we're just creating a new to-do list with a context path, which basically just tells it what is the root URL of the server. And we have this Buster.env, which has information like this. So this will be the root URL when the test is running inside Buster. And then I just call add, and in the callback, I assert that the item text was the text that I added. And incidentally, this is also showing you another feature, which is asynchronous tests, because this test will be asynchronous because of the Ajax request. And all you need to do is to accept this done callback to the test and call it when you're done. And you have an asynchronous test. I now want to run this test with a couple of different configurations to show you a few of the options we have. So the first one is this. So this is another configuration test where we tell it what files to load. And then we have something called resources. So this is basically an API for just stuffing stuff on the server that will be available when the tests are running. So in this case, I'm saying that this URL should respond with this content and this header. Much the same I did with sign-in, but this time it's actually real. So I'm actually putting it on the server this time. And if I run that test, I need another shell. Oops. Okay. Test, and then you have this, we can specify the configuration file here. I'll say C, wrong directory, sorry. Buster test, C, and then, okay, so we ran one test and it worked. The next logical step, if you have many endpoints in your server that you want to test through your JavaScript, maybe you would like to keep these payloads in files because that's easier to organize when you have many responses. So here's another configuration file which looks basically just the same, but rather than content it says file. And it just refers to another file here. And the JSON file looks like this. And the reason why this is perhaps more useful is that you can use glob paths and you can let the file give name to the URL. So you don't have to, like if I take away this path here, it will just figure out the path from the file name. So you could take away this one and then say, for instance, fixtures and get everything from there. Then you will have every file exposed as a resource on the server. Okay, anyway, running with this configuration file also works. And then the final example is the real integration test because it actually uses the application. So now I don't have any content, I don't have a file, but I have a backend, which is another server. So the Buster server will just forward the Ajax request to that other server and then forward the response back. And this is a little bit cool because when I run this, like so, it also passes. And now if I take a look at this app, hey, my test has added an entry here. So obviously you don't want to do this against your live app, but hopefully you can run your app in development mode where you can do these kinds of tests. Right. One last feature I want to show you from this configuration file here is something that we call a test bed. So this is one of the limitations of JS Test Driver that drove us into starting this project in the first place. When you capture the browser and you run the tests from the command line, the browser has to construct some kind of HTML where the tests can run, right? And if you don't say anything about that, it's just going to create a blank HTML4 strict page for you with no content other than a few script tags. But if you have like other requirements, maybe you want an HTML5 page where you need to be in a transitional doc type or be in quirks mode or whatever in order to test your code, you should be able to provide that file yourself. And so you can. And it looks like this. So let's take a look at the configuration file here first. It's this resources thing again. And this time I'm providing a resource for /. I know that it's a bit magical at this point, but the API is not entirely ready here. But for now, this is how you do it. You just provide another resource for / than the default one that Buster uses. So if I go into my fixtures folder, we can take a look at this file. And it's a simple HTML file, right? But the interesting thing is that I have some CSS here, so I can now actually run my tests under the influence of some CSS settings. I'm not suggesting that you should unit test CSS this way. That's a very horrible thing to do because it's a lot of manual labor. But it's just to show you that you can do this. It might be interesting if you have CSS files for positioning or some ground basic layout things. Okay, and then let's take a look at the test, which looks like this. This is a silly test. Basically, I extract that h1 element, the h1 element, and I check the text, and I check the color, the actual rendered color. Okay, Buster test. It failed. Why? Okay, so I expected this color to be the same as this color. That's a bit of a shame. So I was expecting it to be completely red, but it's just a little red. So if I fix the CSS here, I can run the test over, and now it works. So it's just basically to show you that I'm actually using this file and that the CSS is actually being rendered. I guess you can figure more relevant examples on your own. Okay, so we're running out of time. I want to show you one more thing before we call it a day. Let's see. Okay. Does anyone here use Git? Yeah. This is a project I recently did where this is a feature coming up in Gitorious. This is basically a git log graph, but rendered with SVG and markup. So all the links and stuff here is markup, and the dots going down here and the lines and so on is SVG rendered by Raphael. And I use Buster to test this. And as I already said it a couple times, I like to do this the T to D style, write a test, watch it fail, and implement, and basically run the tests a lot. So one thing I need is to run the tests very often. That's very important for me. And jumping in and out of the shell is fun for a little while, and then it starts getting tiring, right? So we have, let's see if I can find a file here. That one, for instance, I can run it like this. That's okay. But I decided that it would probably be better if I could run it inside my editor. So what I did was to add, this is a very strange editor that almost no one ever uses. It's called Emacs, but it can do a lot of interesting things. And one of the things it can do is to run Buster tests like this. So if I now just fail this one, every time I save the file, it will run the test inside my editor. And if I go down to that second window there, I can hit Control and key down, and I will be jumping between paths in the stack trace. And then I can hit Control Enter to be positioned at the exact line where the error occurred. And this is getting very useful because now the test report is just next to my code, and I can hit a simple key to jump right into where the test came from. So, this is just a start. We also have things like I showed you previously how we could disable tests using this feature. I can now flip that with my keyboard. Or I can flip all of them. Yeah. And we're working on other features like this which will help the whole testing process. And this is the first thing we did because both of us who are developing this use Emacs, but we also plan to have tools for at least Eclipse and IDEA, and maybe some other tools later. If anyone is interested in helping us, we'd very much like help. So, yeah. I think I'll leave it at that. If anyone's interested in trying it out or learning more, you can go to Buster.js.org. Currently, it's not properly released, so you'll be met with this page. But if you add your email address here, we will email you when it's stable enough to use. And if you want to try it right away, you can just hook me up on Twitter or email or whatever, and I'll give you some getting started documentation. So we haven't got that to the website yet, but it is possible to use it today. Right, so I think I'll leave it at that. Does anyone have any questions? If it will be on GitHub. Currently, it's on Gitorious. Yeah, it is public. Gitorious.org/Buster. All the code is there. Maybe we'll put it on GitHub too. Yeah, we can do that, I'm sure. Yeah. Other questions? Yep. Right. So, yeah. So the question is if you can have integration-style tests where you simulate clicks and entire user interactions, and currently you can't. And I don't know if we will, because this really is geared mostly towards the API level testing, and I haven't really thought about it enough yet. But there are quite a bit of other tools that can do this for you, and I haven't really looked closely enough at them. So we'll have to do that first before we, figure out if we're going to add this here too. Maybe. Yep. Anyone else? Yep. Sure, we can do that later. I'll be at the party and or here, yeah. Great. Other questions, comments? Yep. Most of it is tested with Buster.js, and some of the bootstrapping parts are tested with some lower level tools that resemble something that I showed you earlier today. So the most critical, low-level parts are tested with some manual stuff, and then everything that builds on top of that is tested with already tested part of Buster. It's a bit of an Inception-like thing, but yeah. Anyone else? Should we see if anyone wants a book? So what was the hashtag? It's FEC11 and Buster.js, is that right? Is this right? Yeah. What? You did it wrong? Okay, so we'll pick two right away. Okay, we'll pick one and then one. Lorenz, Simon, Jose. Are you here? Yeah. Hey, come grab your book. Applause for Simon.
Thank you very much. Yeah, that's great.
There you go.
I enjoyed.
And one more. Julian, are you here? Come grab your book. Applause, applause, come on. There we go. If anyone wants to talk to me, I'll be around for the entire evening, so I hope you enjoyed it, and thank you for listening.
So, short introduction, what now happens. Basically, we are done here. We comment, it goes, well, the evening comments in the Ambossrampe, Zürich. For the people who don't know who this is, there is a map on your badge, or we will go at 5:30. We will leave all together, so around 100 people walking to Bahnhof-Oerlikon could be quite funny. Some information for tomorrow, maybe you've seen it. We will have tomorrow unconference. Means that actually every one of you can be one of him. Means if you have an interesting case about Buster.js 2 or whatever, be there tomorrow at 9 o'clock, and I really suggest that everyone is there at 9 o'clock, because then people can raise their hands and say, hey, I'm having an idea for a presentation on Saturday, and you can vote. So it's not that everybody who wants really can do it. It's really that the community or we all decide what we will have on Saturday. And it only doesn't need to be a session. This could be also like a workshop or a sprint. Like we have these 3 rooms over there, we can split up in 3 single ones. So if you need a 20 people room for half a day, if there is space, do it, no problem. Yes, any questions? No, then thank you very much and have a great party tonight.
Embedded in the slides if you want to take a look at it. I forgot to show you the URL and now I'm screwed. So this is my Twitter bitchy handle. So if you find me there, I'll tweet the URL to the slides. Okay?